seagrass people talk about deep areas. To the purist deep sea biologist, anything less than 1,000 meters is a puddle. But so the kind of depth range I'm going to be talking about today is from about 200 meters to about 800 meters, which is where most of my deep sea corals live. So deep coral distribution, status, and management. And again, this is, oops, there we go. Make it stop.
You get too many?
Yeah.
That's a slide.
Oh, I see. That's what, okay. All right, so I'm from Florida State University. I've probably spent the last more years than I care to remember working on deep sea corals in this area and others. And so what I'm going to show you today is a very sort of high-level view of about 25 years, not me, 25 years of research that has gone on in Florida and in the, I won't be touching on the Gulf of Mexico, the northern Gulf of Mexico. I'll be sticking to the West Florida slope and the eastern Florida. Okay, so what are they? Well, Dr. Stephen Cairns, who's the world authority on deep sea corals, came up with this not so nifty definition, but basically they're cnidarians, anthozoans, and hydrozoans. They have calcitic skeletons, either continuous or spicules, or proteinaceous skeletons. And to you coral people out there, you're sitting there thinking, well, this is exactly the same as the shallow reefs, and that's true. Taxonomically, we have the same suite of types of species as we do in shallow reefs. There are very many similarities between shallow and deep reefs, which I don't have time to dwell on, but they do contain the same types of species. There are differences, however, as one would expect. They are, unlike our wimpy tropical corals, found in all of the world's oceans. And so there are actually, we estimate, more deep sea corals in the world than there are shallow water corals, especially with the trend in shallow water corals at the moment. They're most common between about 200 and 1,000 meters. NOAA, in its infinite wisdom, defined deep sea corals as anything greater than 50 meters, which creates a little bit of confusion because it includes some of the mesophotic reefs, which are a completely different ecosystem. So I'm going to be talking about those greater than 200 meters today. They live in the dark, so they can't use zooxanthellae like their shallow water counterparts. They feed on organic material and plankton. They live in cold water between around 4 and 14 degrees Celsius. They live on topographic high points. Most of them need hard substrate, as do most shallow water species. They are often a long way from shore and in international waters, which makes them a nightmare to try and manage. And they are vulnerable to human activities. So the main reef building species, like shallow water reefs, are stony corals. Unlike the shallow reefs, however, we have a very low diversity of the reef building species. They're all branching, and there are about 5 of them that we classify as reef builders. Out here, we have 2 of those species, Lophelia petusa, which is this one here. It is by far the most well-studied and probably the most common deep-sea species in the world, and it grows throughout the North Atlantic, into the Pacific, South Atlantic, and it forms the reefs out here off of Florida. We also have Enelopsamia profunda, which is endemic to the Western Atlantic out here. So yes. So these are the reef builders. Then we have other stony corals that increase the diversity of the reefs. There's a little cup coral and madrepora that create the structure. Same as shallow reefs, lots of structure, lots of animals associated with it. Black corals, some of these can be very large. This is one that I photographed 2 weeks ago off of the Portales Terrace. It was over 3 meters across. These are very slow-growing species, and they're called black corals because of their skeleton. Obviously, we've got a white black coral, an orange one, and a red one. So they're named for their proteinaceous skeleton, which is also actually used for jewelry and curios in some places. It's harvested for that. A black coral was aged a few years ago and is found to be 4,270 years old, which makes it the oldest animal on Earth. So we're using these things to make jewelry. So I'll stop there before I get off on my soapbox. Gorgonians, similarly to shallow reefs, are the most speciose, and quite honestly, they're taxonomically a bit of a pain in the head. We know of about 2,300 species in the deep sea at the moment, and they can be very large. They provide habitat for other species. They're a very important component of many deep reef species, but they do not build reefs. Sponges are also extremely important. They're even worse for us taxonomically. So we know that they're very diverse, but we have no idea how many species there are. Hexactinellids, glass sponges, are characteristic of the deep sea. And these are just a few examples from the southeastern US. So threats. Being far from shore and being in deep waters does not protect them from us. At the moment, destructive fishing is by far the biggest impact globally, physical impact, bottom trawling specifically. Harvesting of precious corals, as I said, deep sea industries. This not only includes oil and gas, but now the burgeoning deep sea mining is threatening many, vast areas of the deep sea, including seamounts on the high seas. So that's going to be a problem for now and for the future. And then this looming thing of climate change that we really don't know how it's going to affect the deep sea. But it's the increasing carbon dioxide is causing ocean acidification, which, without going into the carbonate chemistry, which I'll probably trip myself up on, it is causing a shoaling of the carbonate saturation horizon. So it's basically causing the deeper areas to become hostile for making carbonate skeletons. So that means the corals would be pushed upwards, but that's joined with warming ocean waters, which is pushing them downwards, effectively decreasing that band in which they can grow. So this is just a map of deep coral locations throughout the southeastern US. I'm going to be talking about Florida. Ironically, we have much more information out here in the northern Gulf than we do for these sites off Florida, even though there's probably more corals there. And that's because the money has been invested by the Bureau of Ocean Energy and Management in the oil and gas areas. So down here, this is a very, very dense area. The coral distribution basically follows the Gulf Stream, the Florida Current, and the Loop Current. So we use really expensive vehicles to research these things, and trying to find them is the biggest challenge. One of the greatest tools that we've had in recent years has been multibeam bathymetry. And so we look at the multibeam in the right depth ranges, and we basically guess as to where these things might be before we deploy our assets. This map here, it's not a very good map. I apologize. It's pulled from the NOAA website, but it just shows that all of these little bumps here are lithoherms or bioherms. A bioherm is a mound created by corals. Some of these are over 100 meters high. And these three little blips here are a site we discovered in 2005, and they actually contain about 90% live coral, which is extremely high. And these are just some of those pictures. And actually, before I go off on, okay, I will say at the moment, we are lucky in that our deep coral reefs, as far as we know, are in relatively pristine condition, as much as you can have pristine these days. They're not impacted by fisheries, and they are in really good shape. And so now is the time to try and preserve these ecosystems. So going around the corner to the West Florida slope, this area has been somewhat neglected by comparison with the northern Gulf of Mexico and the East Coast. As far as the Gulf of Mexico is concerned, the reason BOEM has not funded research here is because of the oil and gas moratorium. As far as the East Coast, if you look at the institutions that were studying deep sea corals, many of them are on the East Coast, and they worked on the East Coast. So this became a sort of a bit of an unknown, but we had an indication that there were lots of corals here. And so in around 2010, there was an effort to study some of these features. And what we found was all of these, what looked like insignificant little bumps here, here, and then further south, were actually thriving Lophelia mounds. In 2017, just recently, we went back and found even more sites. So again, this is just a few happy snaps of some of the corals that are down there, but these are extremely abundant, extensive deep water coral ecosystems throughout the coast of Florida. In a recent paper, 2013, my colleagues and I published this estimate, or this paper that estimated how much area of deep sea corals there were around Florida, and it's over 40,000 square kilometers. Compare that with shallow reefs in the same general area, and it's down to about 36,000 square kilometers. So these are big areas and big reefs. This was an area down in the Florida Straits that we recently discovered. It was, again, we used multibeam. It was this little wrinkle and dimple on the multibeam map, and it's within a protected area. I'll talk about management in a second, but it was an unsurveyed area within an area that we defined as an area for protection. Sorry, that was a bit garbled. And what we found was that this is the black coral that was over 3 meters across. Now, the black coral that I told you about that was over 4,000 years old was nowhere near this big. And there were several of them this size in that one area. So I didn't collect it because I just didn't have the stomach for it, but that's probably an extremely old coral, and they're all over the base of this mound. And it was very strange. This is about 400 to 520 meters, and these corals were growing in hedgerows, and this is a growth form we hadn't seen before. And that was just this year. So we are still on the sharp part of the exploration and learning curve about where these things are. So we take all of this data, and in order, and it's, you know, we always collect environmental data if we can, and so we're getting more of a sense of where Lophelia, which is the reef building species, lives. And so we take all this information, and in order to try and make our science into a management tool, we give it to these really smart modelers, and they go back and they basically take information on where the corals are, and they extrapolate it using remote data like multi-beam ocean models and so forth, and they turn it into predictive habitat models. Now, management agencies don't quite have the faith in these models yet to use them as tools, but we're getting there. The more data we get, the more the models are refined, and so we're hoping that these will actually be used by management to try and protect these areas, because we can't get out there to verify most of the time that the corals are there. We know that most of the time we do go out in these predicted areas and they are there, but we're not quite there yet in convincing management to use this as a tool, but we're getting there. So potential impacts on deep sea coral systems in the southeastern US. Now, fortunately, we don't have many of those global problems that I talked about. We have seen a little bit of degradation from some fishing gear, crab traps, some cable damage, and then after the Deepwater Horizon, there was some damage to corals close to the oil spill. These are potential impacts. There is a potential for exploitation of coral-associated species. There are some species down there that are harvested elsewhere commercially. We don't have fisheries for most of them yet, but there is potential. Now, the problem with exploiting deep sea species is that everything grows slower in the deep sea. And so many of these deep sea fisheries are not only damaging the habitat, but they're not sustainable. Climate change, again, we don't really exactly know what's going to happen, but we're going to have to deal with it. And then impacts from the energy industry, which is probably the biggest in terms of threat rather than immediate impact, as the deep sea horizon oil spill, Deepwater Horizon oil spill indicated. And as we start, you know, we've already moved into the deep sea with our oil exploration and exploitation, and that's going to continue as we use up the coastal resources. Okay. There are several, as I said, there are over 70 species of fishes that have been identified from these living in and around these reefs. These are just a few of the ones that are reef associates and that are potential fishery species. There's a couple of species of roughy, a hake. Black belly rosefish is already being targeted by deep droppers, working in about 800 feet. Conger eels are harvested elsewhere, and then wreckfish are also a commercial fishery further north and a recreational fishery down here. The golden crab fishery used to be active in the Gulf. They are now restricted to South Florida. They use strings of traps, and they actually target areas close to the reef. So we've seen abandoned fish traps, and we've seen damage, crab traps, and we've seen damage from the traps close to the reefs. The energy industry, it's just a map of where they operate. As you can see, there's a big bald spot over here. Whether that remains, whether it stays that way remains to be seen, but they are all over the northern Gulf in deep, deep water. So we've got several management mechanisms that we can use to protect deep sea reefs: National Marine Sanctuaries designation, Habitat Area of Particular Concern designation, which is just a fisheries mechanism, can only protect from fisheries damage. Fisheries Management Plan amendments, The Magnuson-Stevens discretionary provision, this is something that was put into the 2009 reauthorization that allows regional fishery management councils to protect areas that have a high probability of having corals, as in we don't have to prove that they're there and we don't have to prove that they're EFH. That has less power, but that's a whole other thing. And then the Bureau of Ocean Energy Management has its notice to lessees, which stipulates that anybody working in the energy industry has to stay away from sensitive habitats. The limit now is about 2,000 feet, 600 meters, I think. Management, in 2009, my colleagues and I have been working down here. Most of my colleagues have been working longer than me in this area. And we had described distributions of corals all the way down here, North Carolina. Another colleague was working in North Carolina, all the way down here, and then on the Portales Terrace as well. And long story short, we worked with the South Atlantic Fisheries Management Council, and in 2009, they established about 25,000 square miles of protected deepwater coral habitat that has no bottom tending gear. We worked with the golden crab fishery on the historical sites to create provisional areas, so everybody got something that they could live with, even though they may have not been happy about it. So, and then we also had royal red shrimp exceptions as well. So it was a good example of working with the councils, working with stakeholders to try and get these areas protected before there was a big impact on them. So we're doing a similar thing in the Gulf of Mexico. There are actually 15 areas that we've proposed. Unlike that nice big swath of habitat in the Gulf, we're looking at hanky-sized areas. So these are some of the coral mounds I showed you from the West Florida slope. Another one down here. These three will have regulations associated with them, similar to the ones in the southeastern US. No bottom tending gear, no anchoring. This one is going to be an area with no regulations. It wasn't considered really, we didn't have enough data to support the regulations. And then this area is Pulley Ridge, which is greater than 50 meters, but is, as I said, a completely different habitat. It's mesophotic, hermatypic, or rather shallow water species like this agaricea. That's created much more heartburn than any of the other areas because there are bottom longliners that are highly invested in these places. And again, this is why we want to get some of these areas protected before people invest their livelihoods in exploiting them. So that's going through. That's a Coral Amendment 9, I think, and it's working through public scoping right now. And I think that was it. Yes.
We've left 3 minutes for questions.
I feel like I flew through everything. They're all obviously shallow people.
So PCO2 is really high down there, so why is there any calcium carbonate skeleton?
It's above the saturation horizon. It's above 1, but yeah. But the Lophelia lives around that 1 and slightly above it, which is much less than you'd see on the shallow reef systems. And we think that's because it's around the oxygen minimum zone, because that's where the food is. So we think there's a correlation there. But it's on the hairy edge of undersaturation. And occasionally it dips down into undersaturation. Lophelia is fairly robust in many ways. It's sort of a weedy species. But most of the work has been done on Lophelia because it's a keystone species. Makes the reef. But what you probably end up with in that sort of situation is losing the sensitive species and ending up with the weeds, which is what we see.